All right, let's continue our discussion on the diesel cycle. Problem number 2. Okay, so we are given a pressure of, pressure of 1 bar, and 1 bar is equivalent to 100 kilopascal. Temperature 1 as 330 Kelvin, and compression ratio of 16, and heat energy in, so in, Q in as 1 to 50 kilojoules per kilogram. So we are to calculate the maximum pressure in the cycle, and from the diagram we can see that the maximum pressure occurs at pressure 2, and pressure 2 is equivalent to pressure 3. So we are to solve for pressure 2. And then next is the maximum temperature, and from the TS diagram, the maximum temperatures occurs at state 3 or at point 3. Okay, so let's solve this one. So pressure 2, so pressure 2 is pressure 1, compression ratio raised to, okay, and this is 100 multiplied by 16 raised to 1.4, and pressure 2 is now equivalent to 4850.29 kilopascal. And this is your maximum pressure. Okay, this is your maximum pressure. Next is temperature 3. So temperature 3 is temperature 1 R to the K minus 1 multiplied by R sub C. So we have temperature 1. How about R? Yes, this is given. However, R sub C is not given. And so we cannot use this equation. But instead, what we can use is this one. Q energy in is mCp delta T. So temperature 3 minus temperature 2. And we are given the energy in terms of kilojoules per kilogram. Q in over M. And so we are now left with this equation. So temperature 2 is temperature 1 R K minus 1, and this gives us 330 by 16 raised to 1.4 minus 1. And so temperature 2 is 1000.37 Kelvin. So we are now ready to solve for temperature 3. 1 to 50. So this is given in the problem statement. And then this is 1.005, that is constant for air. Temperature 3 minus temperature 2. And solving for temperature 3, we get 2244.15 Kelvin. And that answers letter B. Next. Okay, so next is thermal efficiency of the cycle. So cycle efficiency. Thermal efficiency is 1 minus 1 over R to the K minus 1, and this is multiplied by, so this is K R sub C minus 1, and then this is R sub C to the K, then minus 1. Do we have R sub C? Okay, so we don't have R sub C yet, but we have R, and we know K as 1.4. Since we already solved for temperature 3, we can now get R sub C. And we can get that value using this relationship. That temperature 3 is temperature 1, compression ratio raised to K minus 1, and then R sub C. So solving for R sub C. So R sub C is, okay, so this is temperature 3, temperature 1, and then R to the K minus 1. And this gives us, this is 2244.15, and then this is 330, 16 raised to 1.4 minus 1. And that gives us an answer of 2.24. And with that, we are now ready to solve for thermal efficiency. So thermal efficiency is 1 minus, so this is 1 over 16 raised to 1.4 minus 1. Then this is multiplied by, so this is 1.4, then 2.24 minus 1, then 2.24 raised to 1.4 minus 1. And thermal efficiency is, from your calculator, 0.6023. Next, okay, so next for letter D, we are to solve for the mean effective pressure. So mean effective pressure is expressed as work net over volume displacement. So what is work net? Do we have work net? Okay, so do we have work net? We don't have work net. How about volume displacement? We don't have that one, but we can solve for these two. So let's start with work net. Work net. Okay, so where can we get work net? We know that thermal efficiency, so another formula for thermal efficiency is work net over Q in. Over Q in. And solving for work net, okay, so solving for work net, work net now is thermal efficiency multiplied by Q in. This is 0.6023 multiplied by 1250. So work net is 752.875 kilojoules per kilogram. Kilojoules per kilogram. Now we are done with work net. So let's solve for the volume displacement. So volume displacement. Okay, so volume displacement is volume 1 minus volume 2. If I were to multiply, okay, so if I were to multiply just this side, okay, so if I were to multiply this side with volume 1 like this, so volume 1 over volume 1. So am I changing anything? So volume 1 over volume 1 equals 1. So I'm not changing anything. Okay, so I'm not changing anything in this case. So if I were to rearrange this, so uh, volume 1 minus volume 1 and then volume 2 over volume 1. And this one, this expression, okay, can be expressed like this. Uh, 1 over volume 1 over volume 2. Okay, so if I were to continue, this one will become volume 1 minus, then this is volume 1, and then 1 over volume 1 over volume 2. And volume 1 over volume 2 is your compression ratio. Okay, so compression ratio. If I were to continue, this is now volume 1 minus. Okay, so volume 1 multiplied by 1 over compression ratio. If I were to factor out volume 1, I am now left with volume 1 multiplied by 1 minus 1 over your compression ratio. So we are now ready to solve for volume 1. Okay, so we will now solve for volume 1. Volume 1, where can we get volume 1? Using the PV relationships. So PV MRT. So this is where we will get volume 1. Expressing it in terms of per unit mass. So this becomes specific volume. So this is now RT1 over pressure 1. So this is 287. So this is constant for air, the gas constant for air, 0.287 kilojoules per kilogram Kelvin. Temperature 1 is 330. And pressure 1 is 100. And the specific volume 1, okay, so specific volume 1 is 0.9471 cubic meter per kilogram. Therefore, we are now ready to solve for volume displacement. Okay, so volume displacement is now expressed as, okay, so in this case, it will be a specific volume. Okay, so we'll be expressing it in terms of specific volume. 1 minus 1 over R. Specific volume, this is now 0.9471 multiplied by 1 minus 1 over 16. And so, volume displacement is 0.88791 cubic meter per kilogram. We are now ready to solve for the mean effective pressure. So mean effective pressure is, oops, what happened here? So mean effective pressure is, so again, work net over volume displacement. So we just solved for work net earlier. So this is 752.875 over volume displacement 0.88791. And MEP is MEP is 847.92 kilopascal. So let's check the unit. Did we get it right? So what's the unit for work net? This is kilojoule per kilogram. And then volume displacement is cubic meter per kilogram. So kilogram is cancelled. And kilojoule, so joules is Newton meter. So this now is kilo Newton meter. And then cubic meter. So meter is cancelled. So this is 2 Newton per square meter is Pascal. So kilo Pascal. Okay? So that answers all the questions for problem number 2. All right. This is problem number 3 and the solution will be on our next video. So make sure to answer this one first before checking the next video. All right.